back. So I'm Mallesh. Today we'll start a new series of videos. So this has been a long time after my last upload. So in this series I'm planning to discuss the physics pathfinder for JEE Advanced and Olympiad's problems. So the first problem we are going to discuss today is from electrostatics topic, the question number 6 given in the pathfinder. So in this question we are having it's a multiple concept question. So 3 concepts are covered. The first concept covered is electric field, the second one is going to be circular motion, and the work energy theorem also. Let's see the problem and try to analyze, and then we'll solve the problem. So the problem given is this. So a positively charged small disk is released from the top of a fixed hemispherical frictionless dome in the presence of a uniform horizontal electric field. If the disk leaves the dome after an angular displacement of theta is equal to sine inverse of 3/5, find the ratio of gravitational force and electrostatic forces on the disk. Assume that the dome doesn't exhibit any electrical property. That is the question given. So options are given like 4/3 and as well as 3/4, and along with that 9/2 and 12. So these are the 4 options A, B, C, D given, and the diagram also you can see on the right side. So a charged disk is kept at the top of the dome and electric field is acting in horizontal direction. So to solve this problem, let us go forward with solving it. First, let us redraw the diagram so that we can be able to create the image and try to solve it. So first, if I draw the diagram, let me draw the dome first. Okay, this is the dome which is given. Now from the top of this dome, so when you're going to keep the disk here, let us take the disk is starting from this point. Okay, so it is leaving at an angle theta. Okay, so now at an angle theta it is leaving. Okay, this is the initial position where it's starting from rest, and it is going to be, let us take, it is going with v velocity. And on this situation, if it is leaving, as you know, at any point randomly, suppose if it is here, what are the forces acting? One normal reaction and one QE and one mg. These are the 3 forces acting on it. As a result of that, and these 3 together are going to create the required centripetal force so that it will move along the, what you say, dome surface, the circular path basically it is going to follow. Now as you think like the theta value increase, so QE component will reduce and mg component will increase. So now if let us try to first consider, let us try to consider the final situation when it is at the leaving position. So at the leaving point, when it is there, there are 2 forces which are acting. One is QE is acting like this. As a result of that, radially outward QE, as this is theta, then this will be sine theta. QE sine theta is going to act, and as mg is acting vertically downward along the radius, mg cos theta is going to act. As we know, at the time of leaving, normal reaction is going to be 0. Okay, at the time of leaving, normal reaction is going to be 0. So necessary force is created by this mg cos theta and QE sin theta at the time of leaving. If we consider mv square by r is equal to the force balancing equation, mg cos theta minus QE sin theta. Okay, so this is equation number 1. Now if we conserve the energy, as this is going to come down by a certain distance, so how much distance it is coming down here? Let us see now. So it is going to come down by h height, and it is also moving x distance in horizontal direction under the action of QE. Now from work energy theorem, from energy conservation, so delta K, change in kinetic energy, is equal to net work done here So two forces are there, one is electric force and the other one is gravitational force. So half mv square final kinetic energy minus initial kinetic energy is 0. This is equal to mgh plus qex. Okay, because x distance it is moving along the direction of fe, and along the direction of mg it is traveling h distance down. Now mv square by r, let us keep it same, one more step we'll take it, half mv square mg, from the diagram h is nothing but r into 1 minus cos theta, plus qe multiplied by, from the diagram x is r into sin theta. If you bring r onto the right side, mv square by r, which is equal to 2mg multiplied by 1 minus cos theta plus 2qe sin theta. Let us take, this is equation number 2. From 1 and 2, we can be able to say that mg cos theta minus qe sin theta is equal to 2mg into 1 minus cos theta plus 2qe sin theta. This is equal to mg cos theta minus qe sin theta. Let us bring whatever the forces required. So mg terms on left side, qe terms on the right side. mg multiplied by 2 minus 2 cos theta. So otherwise take on the other side so that the minus sign we can neglect. mg cos theta minus 2mg into 1 minus cos theta, which is equal to 2qe sin theta plus qe sin theta. When you try to do this, like mg you can take common, so it is like minus of minus plus, and 3 cos theta minus 2, this is equal to 3qe sin theta. So to solve this, as the asked question is F gravity by F electric, which is equal to mg by qe, which is equal to 3 sin theta divided by 3 cos theta minus 2. As theta given from the question that theta is equal to sine inverse of 3 by 5. This implies that sine theta is equal to 3 by 5, which indicates directly theta is 37 degrees. Okay, so theta is 37 degrees. If you substitute in this 3 sine 37 divided by 3 cos 37 minus 2. 3 into 3 by 5, 3 into 4 by 5 minus 2. So when we do this, then immediately F gravity by F electrostatic, which is equal to 9 divided by 12 minus 10. F gravity by F electrostatic is equal to 9 by 2. So this is the answer for this particular question. Thank you. We'll see the another question in the next video.